Hi, sir. I think everyone's here. We can start the session.
Perfect. All right. Just a second. Share my screen. Hi, folks. Morning.
Good morning.
Good morning.
So, folks, what we'll be doing today is a couple of topics that we need to cover in terms of overloads and some parts of threat hunting as well. Moving it on to using MISP. I hope everybody has installed it. In case it hasn't, we'll have a look at it. Also, we'll be interacting with the sticks and taxi frameworks to identify how we can use the raw data itself. And we'll also be looking at a tool called Darkscape as well, which basically gives you another side of CTI information. So in sum total, we'll be looking at how we can look at data, how much we need to actually collect, what are the kind of data that we need to look at, uh, what are the problems in collecting too much data, and thereby then using these concepts itself into using more and more Python and Jupyter notebooks today, where I'll be interacting with raw data and showing you how we can actually source this off multiple sources. Additionally, we'll also be looking at how we can channelize CTI information in WISP and then look at an attacker's framework from Darkscape. So this is what I'll be majority covering today, but we can switch it around as and when how people feel. So today what we'll be discussing is collection overload. So we've been speaking a lot about how cyber threat intelligence can be collected, how it's being associated. We spoke about some problems that last time we discussed with CTI as well. So this is another framework of problems that we look at, which is basically on the side of collection overload. And generally where this comes up from is CTI teams generally, whenever we look at data in raw formats, we tend to scrape a lot of information, whether that is useful, how much of that is useful, what the sources are. Uh, Looking at all of that, it gets very important. And to understand how we can actually collect the right amount of data and also use that data in an efficient way. Tomorrow, if I tell you that, okay, the CTI information that you need to go collect, and which I'll also be showing you via the Stix Taxi frameworks as well. When we actually start dumping this data, it becomes extremely large because there are so many sources that you can actually collect this from, right? And then there's a problem of verified, non-verified, production exploits, non-production exploits, whatever is available to us, etc. And when we start dumping all this data inside, we start realizing that there is actually a large amount of data. And the problem with such data, actually, what happens is that you will start looking at very contradictory data coming in from multiple sources. So even when you're using different kind of sites and different intel, so it can be that you go to IBM XRadar and say, it tells you that something is malicious. You go to Virus Total, it tells you that something is not malicious, right? Uh, you go to some other site, it'll tell you that the same payload is blacklisted in some places. You go to another site, it tells you that, okay, this payload is not malicious, right? What does a person actually infer from this? What do you actually look at? How do you actually look at it? Those are the kind of things that we'll discuss today. Before I begin, any questions from last time? All right, in case there are any questions, just hit me up at any time and we can discuss it then. Okay, some things that we'll be looking at is debunking a concept which we always thought that more data is good. Actually, it also just starts leading to a lot of confusion. So we will be talking about this. We'll be also talking about the types of collections. So CTI information can be divided into 3 or 4 formats that we can pick and choose in terms of what kind of CTI information do we want. We'll also be looking at what happens when we start collecting too much information, and also the best practices in terms of collection of information from multiple sources. So uh, mostly when I speak to any CTI team or any any analyst who's analyzing CTI, or even people who are not in CTI but just generally in the security industry, they will have multiple either vendors or open source feeds that they'll be using to gather information for attack information, IP whitelisting, blacklisting, CTI information, thread feeds that we look at, right? So the concept here starts becoming that when we start channelizing a lot of information into our systems, what we start seeing is that the information normally starts comprehending itself. It looks at giving us a lot of value till a certain point. Post a certain point, what we see is that the info, no matter how much more information we collect, it doesn't help us solve anything. It doesn't help us take a decision in the right way, and also it doesn't help us understand that uh, whether this is actually an attack or it's not, right? So at the end of the day, it doesn't mean that if I give you 30 sources, we're going to pick those information up from 30 sources. It keeps changing with the type of information you have. And that is how we classify CTI information into three broad categories that we talk about. So there's a saying also what Richard says. It says that once an experienced analyst has the minimum information necessary to make an informed judgment, obtaining additional information generally does not improve the accuracy of his or her estimates, right? Additional information, however, leads the analyst to become more confident in the judgment to the point of overconfidence. So what we're trying to sum up is that after you collect certain amount of information and that information has become viable, no matter how much more information we collect, it's just going to keep adding to a concept called as overconfidence, which we will be discussing, and it will also lead you to jump to conclusions much and much faster. In terms of the type of data that we can collect, there are three types of CTI information that we look at. The first being raw information. Raw information is available with everybody. You go anywhere on the internet right now where you look at CTI information, you will find raw information available everywhere, right? How you process this information, how you look at this information, etc., is all your prerogative. But generally, this raw information is available in most open source feeds that we get, and this part of the information is generally free, right? Why? Because everybody is collecting this information, dumping it in one place. Nobody's actually verifying it. Nobody's actually looking at it to process it. And how much of this actually is valid and makes sense is something which is very difficult to do, because the source of this information also is generally not categorized. Now, to give you examples of raw information, this is any information when you go up and you search, say, on any of your sites like even VT or even Xradar, etc. as well, right? When you search for any of these information, or you go to a CDI site where basically they give you a report which is unvalidated, it's not signed off by any of the known brands that we know. That type of information, when we're sourcing it, is considered as raw information. Similarly, if you also go say on the deep dark web as well, and we're scraping deep dark web and getting information there, that information also categorizes under raw information, because it is not being, number one, vetted by somebody. Secondly, it has not been authenticated as the data is actually true or not, and there are no physical studies being done on that data. Any questions on this?
No.
So generally, Dhruv, this like the dark web data is generally it is not available on the internet. So
Yeah.
from the threat intelligence point of view, what is the best approach to get those data?
Yeah, I would channel it in two ways. Number one is that You have certain open source feeds which scrape this data and store it with them, and you can query them for this data. The second way of doing it is that you have an isolated cloud framework somewhere that you're basically looking at scraping dark web data, but doing it in a generic way. So whenever you are looking at any sort of exposed data, there are certain forums, channels, marketplaces, etc., that you will actually have to look at. The idea here is not to scrape data to specific an organization. So scrape generic data, dump it at your end, process it, and then filter it for any organization that you want to look at it.
Okay. So if I compare this with the real-time production, like the thread, so how much this the feed is reliable to provide the relevant information, because everyone and the all the vendors, they are managing and maintaining their own feeds.
Yeah,
And when the feed is providing the data to this CTI, they all having the different categorization and they all have the different results. So how can we trust on those feeds?
absolutely. So just a couple of things, if you remember, when I was talking about threat feeds versus threat intelligence, there is a difference there in terms of what we're getting from our vendors as on date and what we actually classify as threat intelligence, right? If I break it up into the two aspects that we discussed, threat feeds aids threat intelligence. It is not threat intelligence, right? Threat feeds only lets you know about certain IOCs or certain tactics or TTPs that we talk about certain malicious analysis that the same vendor has done or has picked it up and verified it. That's why these feeds are generally paid. The same source of information for these feeds are available in multiple sources as well. The only problem is that people have not verified it, right? So in terms of reliability of paid feeds, if you're asking me, it is generally spot on because these type of vendors that you're talking about are seeing a lot of data, they're consuming it, they are verifying it, and then they are publishing it. For the same kind of information is available in open source feeds as well. The only problem there becomes that nobody has actually verified it and nobody is actually looking at it and saying that, okay, is this actually an attack or not? So, looking at your thread feeds that you're currently getting from your vendors, yes, it isn't part of it. They are doing a good job on it. But like we discussed in the pyramid of pain as well, that this information changes extremely frequently nowadays because we have cloud computing resources available with us. If we have specific domain names, if we have, say, hashes, if we have IP addresses, these things change very, very frequently. So it depends on the age of data we're also getting.
So basically, if the business, if the management ask, is this report is reliable, then the answer would be no, because all the data, everything is getting changed frequently.
Again, confusing both aspects. We were talking about thread feeds. Thread reports are something different, uh, which generally provided by a vendor are fully vetted. So if you're talking about thread feeds, yes, there is a certain percentage of lower reliability over there. In terms of threat reports being published by organizations, those reports generally by good organizations are spot on.
Okay.
So just to differentiate here again, thread feeds can be IP addresses, hashes, anything that is aiding you to do your investigation on mitigations. Threat reports will generally talk about an attack methodology. They will look at how somebody is actually derived an attack, what are the steps, uh, map it to one of the CTI frameworks that we talked about,
Mhm.
and then provide you that information. If it has been mapped across to a CTI framework, then it actually makes a lot of sense in terms because people have verified it. It will have followed a certain process as well. So we can rely on it. If these reports are just generic in nature, where they're just saying that, okay, so and so kind of information, and they're just picking those things off the internet and publishing it, then reliability goes down. So we should always figure out whether any report that is actually come in is using any kind of framework that we had discussed. If it is using frameworks, then you can be pretty sure that they've done their research on it.
Okay.
So again, I will just look at the source and the source of information. That's all. Okay. Any other questions?
I think no.
Okay. All right. So
Dhruv, one clarification here. So when we talk about the dark web intelligence we are getting from dark web, that will be coming under exploited data, right?
let me just complete all three of them. Then I'll discuss it with you. Where dark web falls in all three of them actually. You can't classify it under a single one. But I'll
Okay.
discuss it. Uh, the second type of data that you're actually pulling out can be exploited data, right? Now, exploited data is generally in terms of people providing information from their own systems by saying that, okay, we saw so and so kind of attack against so and so kind of framework, library, production system, anything that exists on the internet as on date, and they perform some type of analysis or reverse engineering on that and let you know that this is how somebody is trying to attack a system using so and so kind of steps. Now, in this kind of information, this data is generally analyzed by multiple analysts or a single analyst. It has a lot of information in terms of raw information that you will have a lot of technical details. It will be providing you a lot of jargons in terms of what actually happened, right? It will also have snippets of their analysis. It'll have a step of their analysis. They'll probably refer to certain methods of analysis as well. They can refer to certain papers which they used in terms of analysis, and they will try to publish certain IOCs that you can put into your systems and you can put into your reports, and you can get the similar kind of validations from your systems as well. Also, you can get the similar kind of alerts from your systems. So in general, whenever we see any type of 0 days etc coming up, whenever we see any type of attacks etc which are sprouting up, we see a lot of this information coming up, where I think last you would have seen something in log4j as well, where there were extremely extreme amount of information coming up from different vendors with different kind of analysis, with people giving fixes every day etc. So for this kind of information, which is actually coming into us, is also called as exploited data. Why it's called exploited is because somebody has picked up this information, verified it, analyzed it, included some analysis, and then published it to you. So this information can be that I, as an analyst, am going through over raw information. I am going through, extreme amount of raw information. I see the pattern in that raw information. I pick up that raw information and start channelizing it, analyzing it, and then giving it to you by saying, okay, this is an attack that I can see, and this is the information that I have published with why I'm seeing this attack. Any questions on this? Okay. And the last part is around production type production data, CDI, where we look at raw data being very, very limited, right? This information will not have too much analysis in it. It will just have very simple wording in terms of what you need to do. It will probably suggest some actions that you have to take, whether you need to block something or you need to, just take an IP address or a hash or something and put it there to validate it. And this type of information is generally taken and spread across the industry in terms of notifications, what your certs are doing at the moment. This is all called as production CTI. So Generally, when we talk about production CTI, any type of reports which are very generic, arbitrary, and do not have any analysis to it, but just is saying that, hey, this sort of information is happening, this is happening today, this kind of CTI information is coming up, uh, please beware kind of things. So this is something that we classify under production CTI. Any questions on these three fronts? Now, to answer your question on deep dark web, it depends on the type of information you're picking up. So classifying a source is not correct. Classifying data is the right way to go about it. The source can be even surface web, but it depends on the type of data you have. If you're picking up a evaluated, analyzed report from even dark web, it goes under exploited data. If you're picking up information which is very raw, it will fall under raw data. Does this answer your question?
Yes, Dhruv. Yeah.
Perfect. One more thing that's important to analyze here is the noise and reliability that we look at. So for raw data, generally some people oppose me on this fact and look at this by saying that, hey, you're not actually making sense here. So let me know if you guys think the same. But in terms of raw data, we have extreme amount of noise coming in because it is coming in from multiple sources, is unanalyzed. It can be anyone dumping information here. But we say that the reliability of this data is the maximum. And why we say that is because this data is untouched. It doesn't have anybody's view or purview on it. Nobody actually has looked at this data before, and it is free from any kind of bias that we look at. Any questions on this?
No, I completely agree.
All right. Uh, on the other end, we say that production data has lower noise. Yes, obviously, because people have filtered it out, they've churned out the right sort of information. But again, they have picked up their own bits and pieces which make sense to them. Whenever you do get production data, it can be that they have omitted certain facts which they find are useful or not useful. Uh, Generally, people in production reports have their own type of information coming up. Whatever is important to them, they will publish that. They might omit certain areas which might have changed your views or analysis from it, because at the end of the day they need to send this to a wide audience. They cannot put in too many technical details there. So the reliability of this information starts diminishing because it has been through so many hands. In terms of exploited data, we do have lower noise but medium reliability here. That is the only reason why exploited data at the moment is maximum consumed by people, or by even say your vendors that you're looking at, because it has just a single touch in terms of people reading raw data, and it has a lot of analysis information that once you go through these reports you can actually form an inference on your own. In exploited information, they will never tell you that block this, do this. They will just tell you these are the IOCs according to us. This is what we are seeing. This is the evidence to support it, right? Take your action on your own. So whatever information you receive nowadays from your vendors in terms of any CTI information, whether you want to call it threat feeds or you want to call it any threat intelligence that you're getting, in this kind of format, you are getting maximum in terms of exploited data as on date. Production data, yes, you are getting from multiple vendors, multiple sites. Everybody keeps sending you a mail now and then that so and so has happened, blah blah blah. Certs are sending this. You get notifications from multiple organizations, governments as well. But again, I would always take that with a pinch of salt. Any questions here? All right. In terms of analysis, now that we looked at the data, we just want to look at the type of analysis that are there now. One, obviously, being that you are churning out multiple amounts of data or looking at the sum of data, you are just specifying and focusing on that sort of data and driving your analysis basis of the data that you have. The other analysis that you have is basically conceptually driven analysis, where you try to derive a certain result by saying that, okay, this is the concept that I'm thinking about, this is what I need to infer, and then you basically start capturing information basis of that. It is not like one is wrong. I mean, I'm sure mostly everybody would say data driven analysis is the best thing. I would disagree there, because there are some parts where data driven analysis is very good. There are some parts where conceptually driven analysis is very good, and we will experience this as well by looking at raw information. And over there, you will realize that data always doesn't lead to the right path. And why that is so is because sometimes data can be misleading as well. Do remember that whenever we are consuming these feeds, attackers who are planning these kind of exploits, etc. as well, also know that this information is going to be available with you. So most of the time people try to mislead certain amount of analysts and SOC engineers with false data being spread across CTI for a certain amount of it or for a certain attack. It's just like, that people are looking at these things, so they will try to mislead you with false information, try to lead you in some different direction altogether. So always relying on data in this also doesn't make sense. Always relying on concepts as well doesn't make sense. So a mix of two is actually the right spot to look at. But again, there are certain spaces where you will not be able to use data at all. There are some spaces where you will not be able to use conceptually driven analysis at all. Talking about the problems, right? Uh, the first problem that we look at is circular reporting. And in circular reporting, sorry, the problem that you see is that on one source of information that you're getting, right? If people keep reading more and more of that information and they get that information to you, everybody is going to come up with a different kind of analysis with a different inference, because this data is arbitrary. So don't think that I'm giving you one final report and everybody is reading that report and coming to you and saying that, okay, this is the meaning of that report, right? What I'm saying is, you are looking at the original source of information. That means you're looking at the raw data. And then individually, if I ask you that, what is the problem? What is it that you're seeing? Say person one, person two, and person three will always have different inferences that are coming up. Hence, if you had read that original source yourself, you will also infer something else. You will see people putting in their own biases in terms of more and more people who are reading it. And this generally starts becoming a problem. And why it becomes a problem is because now you are confused in terms of what you have read. You are confused in terms of people who are reading it and putting their own bias, and they might have been correct in the past. So you try to infer your thoughts also basis of that. Any questions here? Yeah. All right. The second one being around collection bias, and this generally happens with everybody. me being is, I mean, I've also faced this multiple times, is that when you are collecting information or threat feeds or threat intelligence from any source, generally one source starts becoming more and more your go-to source rather than you collecting it from multiple feeds. So I don't know if you guys have looked at threat feeds or threat intelligence in the past, but generally a lot of people, when they have like multiple vendors, they prefer a single vendor to choose information because it might have been correct or it might have been their choice before as well, or they just generally like it. But what it does is that when you don't have multiple sources of information coming up and validating it, it tends to skew your assessment completely. So it can be that I say, okay, source one that I'm getting information from is my most reliable source. Hence, whatever they say, I'm going to trust it. Even if I have source 2 and source 3, I might assume that these sources are not correct always. So hence they're not correct right now as well. Any questions here? All right. The third problem that we look at is overconfidence, and the best way to discuss this is via horse betting. So generally the problem with overconfidence is that if you have certain amount of information that you're picking up, so if like say that I have information, raw information about a specific horse, and you keep adding that information that you keep looking at, right? So for example, I have 5 set of information, 10, 15, 20. After a specific point, your accuracy actually starts stabilizing. So for example, if I have 5 items of information or 10, right? And if I have 20 items of information, my accuracy slightly increases. But if I have say 40 points of information for something, my accuracy starts decreasing. But the only thing that starts increasing is your confidence. So if you pick up say a specific information from one vendor and you see that happening from a second vendor as well, and you start seeing it happening from multiple sources, so after a certain point, if you keep looking at more and more data and that data actually starts pointing in the same direction where you were heading, it will not tell you that the data is correct or not correct. It will only boost your confidence out. So if you're seeing information coming up from multiple sources, if you're seeing this information coming up from or multiple points of information rather coming up as well, the only thing that is going to change uh, is that your confidence is going to keep going higher and higher. Maybe you are right, maybe you're wrong, but it doesn't help solve the problem that too much data is actually good, right? So there has to be a certain cut that we make in terms of saying, okay, I have got information from 1, 2, 3, 4 specs. That is good enough for me. I should be able to take a decision basis on that. So whenever you're doing CTI, whenever you are looking at thread feeds as well, currently you only say speak to one vendor, 2 vendors. What if I told you that you had a platform which was giving all this information from say multiple vendors and every vendor was saying something else? But you say, okay, 10 out of 20 vendors were saying so and so, so I believe this is correct. Any questions here?
No.
All right. Another problem is of cognitive overload, and this generally people in organizations who are looking at CTI, even security teams that way, especially people working in SOC who are looking at alerts day in and day out tend to face. So what happens over here is that uh, whenever you are providing too much information to say an analyst or to say anybody who's reviewing information, at after one point of time, it starts overloading their brain, right? Once you start doing that, they will spend more and more time to look at the right information and start removing noise out. Also, when you start providing too much information to an analyst, they tend to start losing objectivity by saying that, okay, this is the right way forward, or this is what I need to do, this is the action that I need to take. So when you're actually looking at providing X amount of sources to your analysts, we actually need to review that by saying that, okay, I will provide say one or two sources or three sources at the maximum, but give them short information or short technical information that can help them to take a decision fast. But if I'm just providing them say a plethora of data by saying, okay, this is raw data, this is raw data, this is exploited data, this is production data, right? They will start going crazy because they will not be able to come up with an objective answer because you're confusing them further and further. And generally, I don't know if those of you who have seen thread feeds, if you pick up a specific thread feed from one vendor, you take it to a different vendor, you'll see a different answer. You take it to a third vendor, you'll see a different answer. Now it depends on where you are consuming this from, what you believe in is right or wrong, but actually looking at who's providing more and more technical information to aid your decision. Does this make sense?
Yep.
Yes.
All right. Okay. Now, in terms of how we can sort these problems out, is looking at a concept called as minimal viable collection. And generally, this is a concept which a lot of people use both for CTI teams who are nascent at the moment, who are still developing, and also established teams. So the idea here is that you look up information, you pair it with external data and intelligence, but you always get that information back and start channelizing it with your organization information. So first step, collect data, but collect data which makes sense to you. Don't go looking for data everywhere and say, okay, I will collect X amount of information and then I will channel it back to my organization to make, for example, that it makes sense or not. So if you're in a specific industry, if you're in a specific field, try collecting information only for that industry and field rather than going and hitting generic feeds by getting generic information from people. Do remember your vendors need to serve multiple clients across multiple industries with multiple requirements. They will have very generic information available with them. Sometimes I've seen information with vendors which is available not affecting an industry altogether, but because they're in a line of business with some other industry, they're also publishing that information to you as well. Maybe it impacts you or not, that's a completely different story altogether. The second part is try looking for this information internally first. You will have the most accurate amount of raw information that you require in order for you to take decisions. And when I say that is that look at all your log sources that you can actually start collecting information from, then start channeling it to external sources by going to vendors or going to thread feeds, etc., or going to multiple sharing groups that you have. And another part that we have to look at is which sources are we going to actually start looking at, which sources actually make sense to us. So we have to start figuring out and narrowing down somewhere. If you do not follow these steps and these are not looked at properly, you will again have a huge problem of collection overload where you're collecting information from multiple sources and not using it to its full extent. In terms of source evaluation, should we pick up raw data? Should we pick up exploited data? The only thing that you need to look at is evaluating the source correctly. I mean, does the source of my raw information have, say, much more insights than what my exploited data information is giving me? Secondly, you need to look at IOCs with additional data. It just cannot be that, okay, block this IP address. Why should I do it? Does this information or does this IP address or does this IOC that I'm actually looking at part of an attack vector somewhere? Is it part of any kind of attack previously used? Uh, Anything that you can get additional information on, tie that back. We will be seeing this via MISP as well, how we can do that. But another thing that we can do is complement that information with internal data. So pick that information up, channel it back to your internal data to see does it make sense or not. For example, if I give you that there is an SMB attack going on and you're not using a Windows interface at all, it doesn't make sense to you. So always go back and look at it, complement that information with your internal data as well, and see what we can make out of it. For exploited and production data that we get, right? There are some things that you can tag on yourself or by just looking at it. Number one is you just keep a table in front of you. You keep marking information that you're getting. So when you have sources coming up, you start tagging them to be, say, out of 10 times this source has been reliable, or this source has been, say, not unreliable completely all the time, but sometimes it worked out. So you mark a reliability score for your source. And secondly, what you do is whenever or whatever data you are getting, you start tagging the accuracy of it. So if there is some information that somebody is provided in a report, which they are providing details about, and they're saying, okay, this has been confirmed by, say, XYZ or so and so analysts have gone through it, you can mark a score of, say, 1 on that. But if somebody's just claimed something without providing any evidence with it or any data to back it up, you start doubting that information. So for every report, if you score, say, something like A1, or say you give something like A3 or A2, you score them accordingly like that. Basis of that information, you will be able to get the validity of the source that you're actually picking up from. More and more you store this information, you can actually turn it back and say, okay, so and so source most of the time was reliable for me, or so and so source with their accuracy of data has been spot on. Any question here? Okay. And the last part is using models that you are actually looking at and improving your analysis using those models. So when we are analyzing things without certain models, we tend to bring in our own, say, bias and analysis without actually looking at the correct picture. And if everybody starts doing that, you will have a lot of noise coming into your data. So when you're actually interpreting this information, when you're actually going through the whole analytical process, tend to use one model across your team so that everybody is actually focused on that. They know what they need to do. They know where they can bring in what kind of information. So where should I go actually go for collection overloads? Where should I actually go for, say, reducing my biases that I have? Should I be using, say, a diamond model by specifying or looking at only four things that I need to do? Should I be using whereas? Should I be using, say, the attack framework? Whatever works for you, right? But focus on one model so that everybody is looking at the same kind of information, is trying to derive the same information. So just some takeaways. There are different types of data and analysis, right? More data is always not better analysis. Circular reporting is a common issue which we leave unchecked. It can lead to three problems that we discussed, which is overconfidence, collection bias, and cognitive overload. And in terms of best practices, we discussed three things, which is basically minimal viable collection, uh, validating your sources in terms of accuracy and reliability, and improving your analysis by using models. Any questions on this topic at all?
I think this is it will come with practice only. This theory, I think it is very difficult to comprehend.
Absolutely, I agree. It comes with practice, but just that we need to keep these things in mind sometimes because in our see insecurity, when things pounce on us, they pounce on us in a way that either life is very happy and jolly, or then things will start going wrong and they'll go wrong like one after the other, right? And at that point of time, these things need to be at the back of our head, especially people who are looking at managing teams, looking at resources as well. When you're under attack or when things are going wrong, you will get information from so many places. What do you prioritize? What do you look at? How do you question a person by saying, where did you get that information from? What is your source? Send that back to me, right? So this type of information, although it's theoretical in nature, generally you will use more often than you realize. And specifically with teams like where you have large teams within your organizations and you're reporting to say one or two people, where is that information coming from? Has an analyst heard it from somebody else, or generally what happens is some junior analyst speeds it to their team and their team basically comes to you and talks to it. Their source of information is somebody else, and then they basically leave out certain crux of the matter where you will not have the full information that you require. So open communication channels really help in this sort of thing where you are taking information directly from the source yourself.
Yeah, we can go ahead, Dhruv. I think it will be very difficult for us to really understand this unless we. It takes over time, over years, people's practice. But yeah, this is good to know.
Absolutely. Sure.
Dhruv, is it also possible to take a use case example? You might have actually seen a realistic attack and how this particular use case was actually mitigated with this kind of information that would be coming from a paid resource versus the connect. Because I understand more theoretically versus practical. If you compare it on ground reality, it is still a conversational topic to solve in terms of where that source of information is coming. But I'm just curious, like if you were looking this on more on a real time basis, how that would actually look like.
Absolutely. I can give you a few examples. I can't name vendors or anything, but I'll give you a few examples here. But in terms of, so we do a lot of CTI information captures from multiple vendors as well, and we have our own CTI frameworks built up. Uh, generally what happens here is that there have been multiple instances where there have been attacks specifically on our infrastructure or targeted attacks where we have received information from multiple sources. We also scrape our own deep dark web information as well. Now, what generally used to happen was that we had automation built up on top of this to look at this information, churn it out, and provide us an attack. Sorry, an alert. Now, what used to happen from that is, so think of this that you have multiple sources of information coming in: vendor, non-vendor, open source, non-open source, right? Everything falling into say a piece of code which is basically just analyzing that information, putting it into a nice format and sending it out to you, right? Now, in this, why I've removed a CDI analyst actually looking at that information in the way and just have a simple piece of code running is to improve all the aspects that you're looking at or which we spoke about. Because in the past, I have seen whenever any kind of attack is happening and we're trying to mitigate, generally what happens is people say, I have seen so and so kind of thing, and this is what I am observing. Somebody else will come and say, no, but I am observing so and so thing, and this is why, without having any type of solid information and data with them. So I will not be able to take specifics over here, but generally this is the idea that you as a person who is managing teams or looking at say multiple team aspects that you're looking at, you will have to source information from multiple sources to actually question them what their source of information is. So if one of your teams is saying that okay, so and so information is coming up, and say your incident response team or your SOC analyst team is actually saying no, but I'm seeing something completely different, then you need to actually start diving into the source. And CTI always complements your SOC, uh, always complements whatever your automated incident response that you have, or you might have it manually as well, where your SOC is taking it. So if CTI is not done correctly, it will start deterring people in terms of slowing them down.
Got it.
Any other questions anybody has?
Is there a framework where you can actually ingest what you get from an organizational feedback versus machine data?
Could you just elaborate a little bit as to what exactly you're looking
Because
for?
this the Intel code the Intel code actually come from the systems what you have actually built, and you spoke about that automation you guys have actually created on top of this source of data that could come. Eventually, you need to combine the organizational data that you would actually get. Let's say if one organization has subscribed something from a different source of truth, that information could be fed versus the data that is being analyzed by your internal system. So how would you collate that eventually? Is it also going in line to that and like understanding the or is it in line to this discussion, collating that data that comes from various sources?
Absolutely. So it is. There are a couple of ways that you can do it. Some people do it in their SIEMs itself, if capable enough, that they start tying up. I'm not talking about thread feeds here. I'm not saying that you're just looking at an IP address and saying it's malicious, not malicious. It's about tying it to attack or a framework like attack where you're saying you're looking at the entire supply chain of the attack, right? It's not only that you're seeing recon and you flag recon and your SOC team takes that action and that's it and it's done, right? Uh, it's about where you start saying that, okay, step one of an attack is what I saw was recon. Step two, I saw logs coming in from say endpoints which said that, okay, XYZ is happening. And so then you can actually go back and tie it back to say, okay, now I have the entire attack framework with me ready and say 1, 2, 3, 4, 5, 6 actually triggered. So I can say this is very close to say an APT kind of 30 attack.
Mm-hmm.
Right? This kind of information is started coming up at least in open source SIEMs as well, which I'm predicting will start coming up in paid ones also, say not more than 6 months or 1 year down the line. And many of them have already started doing it.
Yeah.
So they started using standard frameworks where most of them are using the attack framework itself, but some of them are using different frameworks as well, where they're saying that, okay, basis of your log information, they are tying that back to a complete attack in terms of telling you not just block this or because block say one attempt that was coming in, but to say that, okay, this is the kind of the whole scenario that you're seeing. Because when we spoke about it last time also, if you remember, the tactics do not change too much, right? IOCs will change, methodologies will change, tactics and techniques will remain consistent. At the end of the day, there are only 24, 25 tactics techniques that people can use to manipulate your system, right? So those things will not change too much. Yes, software can change, the injection point can change, how somebody is trying to misuse it can change, but detection still remains the same. And instead of you getting simple information by saying that, okay, this IP address is attacking, or this is a kind of attack that say your EDR is stopped. If you get information up ahead before exploit space actually starts that, okay, this attack is looking close to uh, say APT 29 or 30 or 40, whatever, right? In that scenario, you can actually start saying, okay, these were the remediation actions that I need to start taking.
Yeah, makes sense.
Additionally, a lot of people have started using attack frameworks to judge gaps in the system. So for every stage, do I have detection available or not? So what they do is they map the kill chain out, they map attack out, and then at every phase for every kind of tactic and technique that exists, they say, can I detect this with any of my existing systems or not?
And you also mentioned about the open source that is already on par in this thing. Was there a reason to say that? Because I assume that you might have actually seen the community ones are actually more on par in terms of what we might be getting on the commercial side of the world.
Yeah, the only problem with community fed feeds is you will have to spend some time on them. That's all, right? So,
Yeah.
number one, you need a certain amount of scripting skills that you cannot do away with if you're looking at open source feeds. Secondly, you need to spend some time on it. So it's not like you will just subscribe to a feed and that's the end of it. You will need to look at that feed. You will have to churn out that information. You will have to see what type of information is actually making sense to you. Because think about it from a perspective where people are actually taking automated remediation actions using these feeds that we talk about. So if you take a wrong action and for a business like, okay, for e-com, it's fine, you're just blocking a transaction. But say for a BFSI industry where they're actually blocking a payment transaction because of that, it becomes extremely critical. So aid it, don't take decisive actions from the feeds itself. So what
Okay.
we do is, just to give you some insights, what we do is we have a scoring system at the backend. So open source feeds are coming in, tech feeds are coming in, vendor feeds are coming in. So whatever we take, we channel it inside a system. That system is basically correlating it with our SIEM logs that we're getting. Now, for example, say an IP address matches, or say an attack framework, or say an attack pattern matches, right? Where the source is actually coming in from or what the source of that information was, we weighed basis of that. For example, it was an open source feed which I have trusted in the past. I'll give it a higher weighted score, but I'm still not going to take an action on that. So it basically becomes into say a red monitoring kind of thing where it is getting each step of that thing is getting monitored now. And the moment I see a pattern coming up, say either an attack framework or anything, right? That is where the automated incident response actually triggers in and cuts that off. So I'm not taking actions basis of thread feeds. I'm taking actions by saying that thread feeds are aiding it. So it puts it say into a high monitoring zone. And in that high monitoring zone, if something comes up and still is being malicious or still is trying to do things, that is when the actually IR actually triggers in and blocks it.
Sure.
Any other questions? Okay, all right. In that case, folks, just take a 10-minute break. We'll just come back to another topic thereafter, and we will then start looking at a lab. So if you can just boot your machines before you go for this break, your Ubuntu machines available with you. So just boot that up and then we can continue from there. In case you don't have Ubuntu machines, I just need a Linux base. If you don't have that, that's also fine. I just need Jupyter notebooks to be running. So in case you have that installed on Windows, that's fine.
Can we do this Jupyter notebook in the MIS feed, sir, directly, or we have to install it?
So MISP is something different. MISP we used to look at galaxy information, etc. as well. I just want you to look at the raw information before I take you to MISP to see process information.
Okay, so we should have Jupyter notebook installed.
Yeah, if you don't have it, don't worry about it. Just boot your Ubuntu machines up. If you have it already, because if you used it for some different class, then you can just launch that. In case you don't have it, don't worry. It's just hardly a 2-minute installation.
Dhruv, Arshi, last time I did it with your GCP instant, the MISP installation.
I'll have to check the status of that, yeah. If that's running or not, I'll just let you know.
Sure.
But for the Jupyter thing, just do it internally itself. I think the lab machines will be available now. So if you can just do it on that, we'll see the MISP kind of thing. Otherwise I'll give you an instance.
Okay.
All right, folks, see you in 10 minutes. Just make sure you boot your Ubuntu machines up and keep them ready. We'll also just start working on just one topic I need to cover before that, and then we'll work on that. Hi folks, are we back?
Yeah.
All right. So for those of you who have Jupyter installed on your machines, that's fine. You can just launch your notebook itself. If you don't have it and you're using an Ubuntu uh, base for that to get it up and running, I'll just show you the setup. It's just a 2-command setup that you need to do. So the first thing that you need to just check is if you have PIP installed in your system. If you don't, just try a command called pip3. If both of these don't work, then you can just type the command called sudo apt install python 3 pip and install this. So all I'm doing right now is installing the Python package manager. The only command I've used till now is sudo apt install python 3 pip. Those of you who have PIP installed, you don't need to do it to validate this again. I'm just telling you, if you type in the command PIP, if you're seeing this, it's fine. If you see that the command not found, then only you need to run the command sudo apt install python 3 PIP. Post this, there's only one more command that you need to run, which is pip3 installed Jupyter. That's all. So you should see something like this once you run the 3 commands that I've shared. So this is what you should see after that. If you don't see this, you can just copy paste either of these links onto your Firefox in your VM itself to basically run it. It's bound to your local host. It's not bound to your external IP. For those of you who are here, just click on new and click on Python 3 kernel. You should see a notebook come up like this. This is where you should be. In case anybody is facing any challenges, just let me know, please. Once everyone's seeing the screen, just let me know. I'll start then.
I think we can start, Dhruv.
Okay, right. Okay, so what we're going to be doing right now is we're going to be sourcing CTI information from the attack framework itself. So we had spoken about sticks and taxi feeds in our first 2 sessions, and how we interact with these feeds is something I'm going to just be teaching you to see raw data right now. What kind of information do we actually get from this? How can we source raw information from these things? So that is what I'm going to be just walking you through. uh, MISP and all other frameworks, and even TRAM, that what we used uses attack CTI basically at the backend. So I'm just trying to show you what that data looks like before we begin. So this is the complete raw format of data that what we're seeing, and it will basically be iterated over and over to give you a front end UI basically when you use different kind of solutions. So we're just going to be interacting with the raw APIs right now and seeing what type of information do we get from here. So for this, what we need to do is just open another terminal and just run the command pip install attack CTI. What this library does is it invokes all the attack CTI frameworks that we have. So basically sticks feeds, taxi feeds, etc. It automatically installs all of that for you. So you require a taxi and a stick client to basically read from the sticks and taxi frameworks. So the pip install attack CTI basically does that, and it installs the clients for you on your machine. Just to validate your install has worked, you can just type in from attack CTI import attack client. If that command works, then you're good to go. If that command is not working, let me know.
Module not found, it's saying.
Okay, if it's saying module not found, you need to just open a new terminal window, and you need to just type the command pip install attack CTI. If you run that command, if it's saying requirement already satisfied, that means it's installed. If it's installing it, just let it run.
Dhruv, I'm still getting the module not found error. On terminal is showing the requirement is completed.
Just share your screen once, please.
Yeah. Can you see my screen?
Yes, I can.
Yeah, here it is. Requirement already satisfied. And when I go to the, it's still giving me this error.
Okay, could you just go to your terminal once and just type in a command which pip?
I'm sorry?
Which WHICH PIP, yeah. And just type in which Python. Just type in which Python 3. Okay, and can you just type in which pip 3? Okay, could you show me the command you fired once to install attack CTI? Okay, just type the command pip3 install attack CTI. Okay, and how are you launching your Jupyter notebook? Can you just show me that command?
This was the link I used.
Okay, could you just kill this and restart it once? Just hit Control C. Yeah, and just hit the command again. Just open the URL again, which is on the command line. Yeah. Just refresh this.
I'll just reopen it. Which one you want me to use? The second or the first?
Anyone you can use.
For second one is actually giving access denied. I'll copy the first one. Now it ran. Yeah.
Sometimes it just doesn't pick up the new library until you reboot it. So
what you did, you just restarted, huh?
yeah, so just you need to ensure two things. Number one is that the Python and the pip versions that you're installing are the same thing. So that's why if I add the which pip commands and which Python commands, if those are the same, then you can basically just kill the IPython node, the Jupyter notebook, sorry, and just reboot it once. So those who have fired the first command correctly, you'll just need to install one more library. I don't know if you guys already have it or not, but So why we're installing this is basically whatever data we get, we want to basically manipulate that data and see it in a readable format. So that's why I've just installed pandas to basically transform data. And I've also imported JSON to basically look at the JSON formats and interact with the entire JSON libraries from where Stix and Taxi provides their feeds, because both of them provide a JSON input. Let me know once everybody is at line 4 and it's working correctly. In case it's not, sorry, line 2, in case it's not working correctly, let me know.
Yeah, it's working for me now.
Okay. Anybody who's facing any errors here?
Line 2 is working, but line 3, for some time it was fine, but later it's giving error, connection refused error.
Just retry it. Sometimes there's a, uh, I mean, a lot of you must be hitting it from the same IP, so they must be throttling you.
I mean, I'm still stuck on the line 1.
Okay. In case there are any errors, just let me know, please. Just
I mean, fine. I'll check it later on. So, I mean, I think we can continue.
all right.
Yeah, that's the same error I was.
They are not up, James.
Should be the case. I'm just checking unless something has changed. Just give me 1 second.
What's that? Host CT attacks metadata.
Sorry,
Okay, you are trying to DNS resolution of that, is
I'm
it?
just
Okay.
checking where this is going because from one machine it's working or one machine is not working. I'm just checking where it's going wrong. Just give me 1 second. Folks, let's try this after some time. I think this should come back up because from one DNS I can reach it, from one I cannot. So I'm just thinking this is some routing issue which is coming.
So for everybody else, it's showing up because for me, it's showing up.
Sorry?
It's working for me, all the commands which you gave.
Even the third one?
Yeah, everything.
That's what I'm saying. It's working for me on one system, it's not working for me on the other. So I believe this is some routing issue, etc. only.
For me, it's not
Possibly.
working on any machine.
I think it started. I think it started working now. We can continue. Yeah, the object creation is done. I mean, earlier it was showing the error while creating object.
The lift attack client, is that working?
Yeah, it started working. Just give a. I think that might be the DNS issue. Glitch network.
What host are you resolving to? Can you just type the host once on your terminal and see? Just type the command host cti taxi metre.org. Just give me the output of this.
No, for me, it's not working.
Yeah, same here. I mean, it's working on one machine, it's not working on the other.
From last life, for me, it's like I'm praying to God whenever I'm shooting these commands. Please work, please work.
For somebody who's it's working, can they just give me the output for that command, please? Okay.
So, Ashi, is that because you're using a MacBook?
No. I am connected to Reva VPN also. That could be one of the reason.
I'm not. I'm not on VPN. I'm just not on VPN. They're giving the same host name.
Okay.
So the IP is same. It's not multiple IPs.
Can somebody fire that command once and see if that's working? For people whose Lyft client, that command worked.
Yep, it worked for me.
Fantastic. Power of open source. Okay, that is really strange. Just give it one more try and see.
You're not able to ping it, right? Or you're
I'm
hitting a
not
different host.
getting a ping response either. But ping,
Oh,
I'm thinking that it must have switched off. That's fine, but I'm not even getting any call response.
okay. Okay.
And I just hope this is not nothing to do with. Nope.
I think the resolution is taking time because now if you see it's if I put a trace route, it has given the 30 hops and it is not able to resolve in.
Yeah, because that probably will be firewalled, right?
I am actually on my local machine. I'm not behind firewall. I just paste
No,
it.
I'm saying it'll be on the client side firewall, not your firewall.
Okay.
Definitely not a resolution issue. Something I think it'll start working for everybody in some time. Okay, let's just cover one more topic before, and we'll just try this again in probably 15-20 minutes. I think it should start working for everybody. Because that is really strange that it's working for somebody, not for the other. So just give me a second. Let's not waste more time.
Dhruv, can you show the error once again?
Sure. It's basically not giving an error now only. It's getting stuck. Okay, here it is.
Okay, can I share my screen?
Sure.
Actually, I'm not getting error.
Sure.
So it's over here. If you can see my screen.
Yeah, I'm seeing that it's working. That's what it's working for one or two people. It's not working for everybody else. So that's what I'm saying. It might be some network problem which should resolve.
Actually, after that, I didn't try the next command because I was fixing this up.
Yes.
So can we continue over here?
Just give me 1 second. Maybe I've just seen what was different. Give me 1 sec. Okay. Just type the next command and see that works for you.
Can you tell me the command, or
Uh,
or
here.
based in the chat?
Yeah, it's already in the chat.
Uh, which one? That technique one?
Yeah. Just name it anything. Just do a is equal to lift dot get underscore techniques.
This command, right?
Yeah.
This shows could not load. I think I have to install the module.
This is no module based, but could you do lift is equal to attack client and put two brackets there, because I don't see the function being defined in the third part.
Here?
Yeah, it's actually a function. Attack client, just put two brace, open brace and close brace after that. Just try that again now. Yep, this is what is getting stuck. Cool. Let's just try it after some time. I'll just
If I try without bracket, it works.
Yeah, because that you're just basically assigning a variable, right?
Mm-hmm.
You're just putting lift's values attack underscore client.
Yep, this worked.
No, you just you have to call the functions there. You can't not call the functions. Just do print on techniques. Can you just do a len of techniques? LEN.
Okay.
And in bracket just put techniques. So you're basically not calling the function, right? So it's factually empty. You're just assigning that value to that. If you call the function, then it basically starts breaking. Anyway, we'll pick it up after some time. Let's not waste more time here.
Okay.
Hoping the issue is temporary and gets resolved, but let's see. Okay. So we spoke about collection overload, and we spoke about what is the right size of data to collect, etc., as well for different kind of sources and all. Another topic that we want to talk about is basically quality over quantity again, right? So this just adds to the topic that we'd spoken before. Uh, we get a lot of questions like, I would like you to review and identify gaps in what we know about a high priority threat actors going into the peak season. But again, you have a lot of sales, you have a lot of times when your traffic peaks and people generally want to attack you at this point of time. Now what generally happens at this point of time is that you want to start doing your threat analysis, but how do we do it, right? So that question keeps coming up, and CTI generally aids in these kind of functionalities where if there are any threat actors who are targeting you at any specific instance of time, then they start reflecting over here, right? So how do we do that? We identify our high priority threat actors. We figure out what we know about each other. So where do we find that information? How do we find that information about the threat actor in itself? We match it to one of the frameworks, and then we perform a gap analysis to say, okay, this is the techniques that this threat actor uses. What can I detect or what can I not detect that this threat actor actually uses to infiltrate networks? Okay. In terms of data collection, etc. So what we do is we dump IOCs and TTPs, right? We extract the TTPs from any sources that we have about the threat actor. We get multiple IOCs from CTI feeds, threat feeds, etc., and get them, clean them out. We merge them and we visualize them, right? So what we do here is that we're trying to get a clear understanding from each TTP that the threat actor has and the IOCs that we've been able to capture. How do we start merging this information in now, right? How the ways we evaluate them is basically around a specific attacker's repeated behaviors. So what kind of attacks have they done in the past? How frequently have they changed? Have they always been the same? What has exactly changed? We find that out. Secondly, we find out the volatility of our IOCs. How frequently do they change? Has the domain been reused multiple times? Have the IP addresses been reused multiple times? Has the hashes been reused multiple times? Is there any package, etc., which has been reused multiple times, right? Third, what we want to do is that in which life cycle or which phase can we detect them, right? Uh, where can they actually work without any detection? So we have to find out our weaknesses by saying that, okay, in this phase is something that this threat actor does so and so, but I do not have the capability to detect them. Or you say in this phase, the attacker does so and so, but yes, I have the capability to detect them. And this is where I can actually start stopping them. Fourth is around the intel that we receive. Again, remember IOCs, etc., that we get expire very, very soon, especially with the cloud space coming up. So is the intel that we're actually getting good? Is it actually that we're seeing that it's not outdated in a format that we've got? We merged our TTPs and IOCs, but we set that up for detection also, but somebody else uses something else and comes up and then we actually miss it altogether, right? And last is around where we can concentrate our efforts to basically mine data or to mine intelligence where we are weak. So I do not have remediation technologies or detection technologies in say phase one where somebody is doing recon. So that is where I start concentrating all my efforts to get information about the adversary in the first place. This is how you will start covering gaps in terms of understanding. For example, if somewhere in the kill chain in say phase 4, 5, 6, I'm very good, but at least in phase 1, 2, 3, I'm not good. In that scenario, we would want to start mining as much information as we can for that specific actor or that specific adversary in those phases. What that does is it helps us to know that what we can detect and how early can we detect them. If I talk about the attack life cycle, right, what we then do is we assign the IOCs and TTPs into attack framework, right, and see where in the life cycle do we want or what do we know the most about. For example, in the life cycle, say if persistence, privilege escalation, defense evasion, credential access is something that we know maximum about, and I do not know about certain phases in the life cycle itself, right? So what we start doing is we now know where we have maximum information. We now know that I can control. So when somebody's trying to gain control, when somebody's trying to execute in the process, that is where I have enough information and enough detection, but I do not have any information in terms of where how they will recon or how they will weaponize their payloads and deliver them, right? So now I have an area where I know I can work, where I know I can get information, and where I know I need to focus my entire collection process. Any questions on this? Oops. Okay. All right. Now, how do we start visualizing these things? You take any attack life cycle that you have, or sorry, any kill chain that you have, where you say, okay, we have recon, we have weaponize, deliver, exploit, control, execute, maintain, and you see the number of items that you have in terms of each phase. For example, if I have a lot of information in terms of how somebody is going to gain foothold or deliver that into my environment, then I basically have a color coded chart to understand where my focus needs to be. Now I know in the recon and weaponized phases, I have no information of what is happening. I have very less information once the attack is basically delivered. What happens after that? How do they actually establish control? How do they actually establish or maintain that hold that they have? I have very low information on that, right? So what you're basically trying to do is assess where your maximum need for CTI data is required. The next thing that you do, we spoke about the pyramid of pain, is that you assign the IOCs basis of the pyramid of pain and see their potential volatility. So, for example, if the IOCs that you have captured, you have hash values only, right? Now hashes can change very easily. For example, you have IP addresses, again, can change easily. But for example, you have tools that you have as information, right? Now tools will not change that frequently. If you have some TTP about the threat actor itself, it will not change. It's not easy to replace it. So what we have to understand is, number one, how dedicated is the attacker towards us? If they are very, very dedicated and something which is sponsored and all, they might even end up changing TTPs. But in that scenario, you can't actually do anything because we don't have the tactic mechanism only to detect it. But like I said, the TTPs in itself are limited. They don't change very frequently. So what you need to realize is that as you keep going above in the pyramid, changing these values gets that much more costly than say simple, uh, non-simple, difficult, non-difficult, forget all of that. But if you are weaponizing, say a malware or ransomware or anything or a specific attack, right? Every phase you go above, it becomes more and more costly for people to do it. So very less motivated attackers who are just doing scans, etc., on your sites, etc., will generally change hashes, will generally change DNSs, will generally change IP addresses. But as you keep going above and above in the pyramid of pain, it becomes that much more costly for an adversary to change these things, to reinvent them, and then to plug it in. But if somebody is very dedicated and they are specifically targeting you, then they will even do that. But we can detect these things still because the TTPs will not change. What will change is the information that you have, which we discussed over here.
So Dhruv, I mean, if I mean, from the real point of view, if I think, then how this TTP is, it will give the more information regarding the sinkhole, because the hash value, IP address, domain, network, artifact, and the tool, these
Yeah.
all will remain same when it comes to the external net world. Okay, but all the vendors, they are using the single IP address, and they are using the single domains to serve the multiple applications. So in this case, how this TTP will work?
No. So number one, this is not victim IPs. These are adversary IPs. Right. So by adversary, we mean that where those IP addresses, etc., are coming in from, or where people want to attack you from, or where they want to establish control from. Okay, so these are like CNC IPs. These are IPs that are actually attacking you, which basically come up and go. These are not victim IPs where I'm saying that for your infrastructure, these IPs, these for your infrastructure, obviously your IP addresses remain pretty constant, or you, even if you're cloud based, you take a certain subnet or something from the cloud providers to stay there, right?
Mm-hmm.
So number one, these are adversary IPs. So when I mean by adversary is that these are the attacker IPs, right? Now, in terms of IP addresses, for example, if I need to attack your network, I know that you're detecting IP addresses, etc., in a certain way and all that, and I start changing that. For me to change IP addresses is extremely easy. It's cost efficient as well. Hash values, I can very easily change of my entire software, of my say attacker that I'm, or the packaging that I'm trying to do with the code, right? Domain names, again, I can change. There are multiple dynamic DNSs that are available nowadays, right? What starts becoming harder and harder to do is when you start changing tools and tactics. Now remember, when I say tactics, there are a limited number of ways that you can attack a website. For example, if you're talking about infrastructure, how will you gain foothold into that infrastructure? There are a limited set of things that you can do. So that is where I'm saying that when TTPs itself start changing. So for example, I was always using uh, say vulnerable software to inject something, and I used to inject a payload and then use say PowerShell to expand into multiple things, etc. Now, if I'm changing these methodologies, that what I'm using is, but remember when I'm changing these methodologies, I'm changing my entire attack surface code. When I'm changing my entire attack surface code, it becomes extremely costly for me to do that. And when I'm saying me, I'm talking from an attacker's perspective here. Until and unless I have real gain out of that coming, I will not basically start changing my TTPs around. Generally, how people do it or how they will actually do it is they package software from known attacks. So you have vulnerabilities that come up. People develop exploits. People take up these exploits, package them, and then ship them. But to move away from one of these exploits and design something completely different, it is extremely costly to do. So in a real world scenario, like you asked me, yes, victims IPs, etc., hash values stay same. But for me to change them from an attacker's perspective is extremely easy. Today I'm attacking you from one cloud network. Tomorrow I'll start off from another cloud network. There are so many free clouds nowadays available for me to do whatever I want. For me to change hash values of exploits, it's also easy to do it, right?
Correct.
But if I tell you that, hey, I'm going to attack Windows in a new way to do it. So for example, if you have a Kerberos exploit or vulnerability in your system and you have EDR there to detect generic Kerberos kind of attacks which are there on your network, or you have say an IDS IPS also there. And when I want to try bypassing that altogether, firstly, I will need to get that technology into my system, test it out, build a bypass for that, then set up a TTP for that, then do it, then use a Windows exploit for that to do it, right? So it becomes extremely difficult to do. So generally what people do is they package 10, 20, 30 different kind of exploits which bypass, say, Kerberos will bypass, say, say PowerShell, or give me admin privileges for PowerShell by using a vulnerability of so and so. Now, these are the kind of things where people send out malicious software and then see if you have a vulnerability and then start exploiting it. If you don't have that vulnerability, they can't do anything. Until and unless I take hold of your server itself and then I'm trying to exploit it after that, that is a different issue altogether. But that is not my MO, or that is not something that you would have researched about any attacker to do. For example, even if you have a public facing web application server, somebody who wants to gain hold of that will have to upload a reverse shell on it. So that's what I'm saying, that at the end of the day, the TTPs do not change that much. The way things are getting attacked, the way things get modified remain pretty much consistent. Yes, the tool can change. Yes, the IP addresses can change. Yes, the DNS names can change. Yes, hash values can change. But the way that they're going to do it will still remain pretty consistent. Did I answer your question?
Yeah, thanks, sir.
Okay. All right. What we are now doing here is that in terms of the data that we can capture about, say, from the pyramid of pain that we had, we start looking at the number of points that we have for each. So, for example, what we were doing. Yeah. What we were doing over here was we were taking the kill chain and mapping the amount of data we had for each persistent step in the kill chain. Now, what we've done is we've taken the pyramid itself and we mapped out the amount of data we have for each step. I have a lot of hash values, I have a lot of IP addresses, but I do not have information about the tooling of, say, a specific attacker or specific person who or adversaries wants to attack me, right? Now, two things that you have found out is where in the kill chain are you vulnerable? Second thing you found out is what type of information do I require about the adversary? So these are the two places I need to start looking for more and more data to figure out if I can gather something about adversaries where I do not have enough information, say, about recon and weaponize and execute and maintain, and I do not have enough information about, say, tooling. The next step, what we do is we plot both of them side by side. So what we do is we take the TTPs, the pyramid of pain on one side and the kill chain on the other side, and we combine these values. Now, what it actually helps you to do is that it will let you know where I have extreme amount of information or where I can also improve in terms of getting or garnering information from the attacker. So when you actually are trying to figure out about specific adversaries and the kind of information that we actually have about them, and what all information do we actually need to start collecting, this is a very good way of looking at things where you would want to figure out what information should I actually go look out for. For example, if I didn't have any information in terms of, say, recon and the hashes that I have, you can start only looking for this kind of information about the adversary itself. So what you're doing is you are going with a targeted set of mind to see that, okay, this is the information I require. And you're not just arbitrarily putting in feeds and saying, okay, this is the feed that I'm going to consume and that is about it. Moving further, what you can also do is you can plot the age of every IOC that you have. Why that is necessary is if you have IOCs which are extremely old or extremely new, they might not be credible in nature because they are extremely volatile. For example, multiple IOCs like IP addresses and hash values are generally picked up from people reporting things on multiple sites. So much so, if you even go to some, say, spam house, etc. sites and you check your own public IP address of your internet service providers, you will see that you are blacklisted in multiple places. Now, you might counter that by saying, yes, these are shared IP addresses, somebody might be misusing them. Sure, but at the end of the day, people are using the same data to plug this data into thread fields, etc., which you guys are picking up and putting it into your intelligence systems. So something which is extremely new and something which is extremely old might not make sense to us at all. Another thing what you can do is you start looking at the data per your kill chain levels that you have. For example, if I have information about say exploit and that exploit data is say extremely old, or if I have information say about control and that information say is say in a median level where I say okay it's between say 50 to 180 days. Similarly, what you can do is you now know which area you need to go collect more information about. Number one, I don't have any execution information. So that is one thing I would concentrate about. My exploit information that I have might be very old or might be say somewhere near the median as well. So that is okay. But how people are maintaining access is plus 250 days, which is extremely old for us. So I might want to go gather more and more data in this phase. Another thing you can chart out is around the TTPs that you have or the pyramid of pain values that we keep, and we chart out the age for those. What you will note here is what is the age compared to the volatility of those things to change. So for example, if my hashes change very frequently and the age is high, there actually makes no use of that. But if something of TTPs I have which is there, which is say even old, it's fine. But something like IP addresses which is say going plus 180 days to 300 days, it's extremely old. So again, you will know where and what type of information you need to start collecting. One thing what we had done was that we were trying to map reports to TTPs using attack, and this basically again shows you which areas in attack uh, does a specific threat actor lie in. But what you can additionally do with that is see if you have detection capabilities for each of those TTPs that exist. So addressing the key challenges what we have over here is that CDI data can be available in multiple spaces that we have, right? So we are looking at pulling specific information. We might have a lot of information for one kind of say we have a lot of information about IP addresses, but we don't have a lot of information about tooling. So you can design custom extraction logics for that, so that I only want information about tooling, right? Secondly, what you can do is that the challenge around data being tracked by different repos is inconsistent. It might even look the same. Some people might even be talking about different kind of things. So even on VT, we were seeing that timestamps were basically different for different for same hash values, because it was actually picking up the timestamp using JS on the client side. So what we need to do is we need to chart out information in terms of volatility and age, and then merge or deduplicate basis of that. And whatever analysis that we have done, this basically should be repeatable. Can we convert it into code? Can we convert it into a Jupyter notebook, etc.? Which is something which I will show you how to do. But this is something that you can keep reusing by saying, okay, this is a threat that we are facing. This is a time that I need to know about things, what are going wrong, what are my detection capabilities, how good am I at the moment to say that, okay, against a specific threat actor, I'm going to be able to detect in which phase, with the existing set of data that I have. You will get to know that. In case you need to source some information for specific stages, you will be able to do that. So like I said, CTI will be aiding you. It will not be giving you a definitive answer by saying that, okay, this is right, this is wrong. If you're expecting that from CTI, it's something wrong that you're expecting. But it will help you understand wherever your gaps are. It will help you understand how you can fill those gaps. It will also help you understand that if I cannot procure at the moment to say set up something in this space, can I use the world of data that we have to detect something at this specific stage or a specific point in the kill chain, to process and to also understand that how I can mitigate that. Does this make sense?
Yeah.
Any questions on this?
The thing is, I think the connecting the dots will be, we are still not in that stage. We're able to connect all the dots.
Okay. Give me a second. You will see the connection come up. That is why I wanted you to first see the data come in, but unfortunately or fortunately, that is not how it wanted us to proceed. But I will connect the dots for you using practicals as well. Okay, why don't you guys take a quick 5-7 minute break, and we'll come back and discuss another part of it. And in parallel, I'm just trying if I can get that to connect or find a different IP address for this to work. If I systems where this is working and show this to you at the moment, and I will give you the Jupyter notebook so that you can try it out at a later stage.
Okay, Dhruv, one more thing. When is the quiz?
This will be sometime today, second half, pending.
Okay.
Right, folks, see you in 10 minutes. Hi folks, are we back?
Yes.
All right. A second. All right. We have been talking about a lot of things in terms of attack, in terms of how we can be using multiple playbooks that we discussed in last class as well, for detecting attackers, etc. Right? This is just another part that I will be talking about in terms of how threat intelligence can aid the threat hunting process as well, right? So attack can also be used a lot in the threat hunting process, which we generally define in terms of how we will be looking at, defining a hunt, etc. as well, and how we can map it back to attack and how we can use the playbooks, which we had defined or looked at earlier as well, and how we can use specific tools to get more and more information about the attacker methodologies. So where does threat hunting come into the entire picture and where does CTI actually come up is you have a SOAR platform, which I'm sure I think everybody, if you must have heard about. Does anybody know what SOAR is? No, is, I mean, doesn't know what SOAR is?
Yes, we have covered in one of the module. This is the security orchestration tool.
Perfect. All right. So generally what happens is that you have a static incident response for everything that you begin with, right? If an incident is there, you start with an incident response process. You bring in some type of digital forensics if required, whether it's at your own systems or your SIEMs or your machines, wherever. You aid that with cyber threat intelligence that we get. We can map it with multiple frameworks that we're discussing about. And then that basically goes back to further investigating into a threat. And that is something that we call as threat hunting, where we look at looking for the unknown, looking at what our tools cannot detect, rather in the process, or something which looks very familiar to real behavior, but is slightly based or is like a sleepy kind of attack that we talk about, which is based in our systems for a very long time, right? To complete the process, I'm just going to be talking about the left side, where how cyber threat intelligence can also start aiding threat hunting as well, using the frameworks that we just discussed. So we have something called as an adversary playbook, right? We have looked at these playbooks as well, where you have certain adversaries, they have certain ways that they can look at attacks, etc. If you are interested in looking at them, I'll just share. I mean, I shared this last time as well, but let's share this again. So you have multiple adversaries on the left, right? And you can select which kill chain you're accustomed to and start looking at what kind of attacks or where in the attack framework itself do they start lying. Or if you want to look at the kill chain itself, you can start looking at what part of the kill chain do they actually start recognizing to. So the idea here is that for every attack or every adversary that we have, we start designing these playbooks so that they aid us to see in what specific areas do they actually come up. Do we have detection capabilities here or not, right? uh, Further going into this, Now, idea here is that we collect their techniques, their tactics, and their procedures, and we start mapping them to every field of the kill chain or the attack phase, and we start getting we start adding defenses that we do in every step. For example, there was an attack on your infrastructure, right? Your incident response triggered it. You did some type of digital forensics. You added that with CTI information to see, okay, whatever TTPs were actually coming did make sense or not. You mapped it to say attack frameworks. You you basically got your TTPs there. Now with each TTP, according to CTI, we also did a defensive kind of mechanism where we said, okay, do we have defenses in place for all these things or not? And then what we started doing was we started observing these against live attacks that we're facing. So with tools that you have, you can start deploying these playbooks that you get for each adversary, map them to CTI, and then start looking for the unknown things that you probably did not detect. Again, why do we do this and how does it aid threat hunting? Because I said that TTPs will not change very frequently. So if you're seeing a combination of TTPs during your hunt itself, you can be sure that somebody has modified something in their process itself and they are trying to target you in a very specific way. But how do we detect it? We still need to do a threat hunt for that. So where does all of this come in? Is that you have an attack life cycle, right? Where you have a phase-based process of an adversary that they must be able to do in terms of completing an attack, right? You have the attack framework now where you have all the TTPs and the common knowledge for how they were attacking you against a specific model. You have the sticks framework now which says that okay, this entire process that you're trying to do, how you can communicate that to cyber threat intelligence forums. And then you have playbooks which basically give you an organized way of your TTPs that the adversaries will use in a format which you can again share with everybody. So now you are equipped with these things. Where we can take them forward is that using the adversary attack life cycles and the identified bases that we've got, we can start building certain indicators as well. How do we do that? Is we consume the threat intelligence that we get. So this was something that I was trying to show you that how this information basically comes up in a raw format, uh, which we were using the attack client for. So all the information that you see on multiple say vendors etc as well, at the end of the day it is available to you in pluggable JSON formats where you can basically pick this up, get information about it, and also see what their TTPs were, right? So when you have this information available with you, how do we start using this in our hunts is something that we'll look at now. I just showed you in the playbook viewer as well that you had multiple TTPs defined. If you go into the details of those TTPs, you will see details of say hashes, file names that were actually used, email subjects that were actually used for even doing a phishing kind of exercise, right? So when we have all this information available with us, what we start doing is that we start doing something called as alert development, which basically does that any alert which is a true positive, right? We start moving those kind of alerts that are very low severity. So you have certain severities defined in your systems where you will say that, okay, I will alert on critical, high, medium sev alerts, but low sev alerts, I will start to ignore because they become extremely noisy, right? Now, in this scenario, what we do is we start moving those low severity alerts to say a hunting program. And what that hunting program basically does is how we can start enhancing our alert profiles in the first place. So we have been saying that, okay, there are certain thresholds that we've been defining. In the long term scenario, we said that okay, SIEMs are getting more and more intelligent, they're using machine learning, but at the end of the day, there is still a threshold that needs to breach, right? Now, whether that machine learning threshold is there, whether that alerting threshold is there, or whether you just say that there's a severity threshold that you said that okay, my SOC will see that any kind of alerts which are below this threshold, they will not action upon, because that is something which we don't look at. It's not severe enough for us to actually even bother about or checking those things out, right? Or their normal behavior that we tend to ignore. Now, in this scenario, what we do is all the low alerts that are coming up, we pick up, we chuck it into a hunting program. And the main objective of this program is to see that whatever alert thresholds that we are actually setting, are those correct? And for this, what we do is we spare some dedicated hunt time for this, right? Now, whether you want to do this at every week or you want to do this every year or you want to do this every quarter is something that you have to see which suits you in terms of the amount of time you can spare for this. But at the end of the day, the objective is to test your systems and your thresholds out to see what you are missing and what you're not. Let's take an example over here that you had received an alert which says that SOC had detected something like a malware in your system. That basically came up from your endpoint, right? If you start mapping this alert back to attack, you will see phases like the tactic being execution, and the techniques applied can be say compiled HTML execution through API, GUI, scripting, third-party software, user egg, right? Now, using this data that you've already mapped to your attack framework, now you know the tactic and the technique that the person was trying to use. What you would do is that you would start piling this information into a hunt program to see, are people actually using the same tactics and techniques to perform different kind of attacks which I am not alerting upon. Another example, if you get a C2 alert from any of your playbook or your source, you say that okay, CNC activity has been detected. You map this again back to your attack framework where you say okay, my tactic is command and control, and you have specific techniques that were used. Okay, where we take this forward, I will just show this to you by multiple tools that are there as well, but idea here is that you pick up the techniques, you pick up the tactics that were used in multiple attacks that you've seen, and start searching for commonly used ports or uncommonly used ports or the techniques that you've all seen. Is there any other source which is generating multiple DGAs? Is there any such source which is using say commonly and uncommonly used ports, for example, right? Similarly, if you go in the previous example here, is there anyone or anything that you're seeing in the attack framework where yes, there was some kind of information available to me, but with a low severity, but it was doing say scripting and using third-party software as well. Now you'll say, how do I get this information into attack in itself? That is where we use the low-level information that we have in the APIs and we map it to the same logs that we're getting. So at the end of the day, what you will see is for every log or every trail of logs that you're getting, you will see attack techniques being flagged at every step. What type of attacker or adversary is actually using these kind of attacks? You can either go back to the attack framework itself and see something called as groups, or you can come back to the playbook viewer and do a common overlap to say, okay, this is something that adversary X was using, and this is very similar to what I am seeing at the moment. To give you more examples here, let's just take a case study of a malware incident, right? For example, we received an alert where we saw an MD5 hash being flagged. Okay, we tested it with say Wildfire. You can use any other solution as well. This was signed by Microsoft Corporation as well. Now, location of this incident currently is at store, right? That you've just got an incident where say PowerShell.exe was flagged, sorry, and execution bypass was used in that command. Okay. We also saw other information like evasion to be flagged. We saw execution to be flagged. Now, how am I getting all this information from here? Is you use your SIEM logs in itself to get all this information and push it to the attack framework. If you remember, in a report structure, TRAM does this for you, that it maps it to a TTP. In a real world scenario where you have your SIEMs, you have APIs driven into attack using the attack CTI framework, where you pass logs to attack and it channelizes that and scripts it into different evasion techniques that you're seeing over here. For example, if somebody was trying to use this and this matches to an execution technique, attack will tell you that this is probably a suspicious PowerShell process ancestry which is happening with TTP value, say whatever T157 blah 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 blah. So in a real world scenario, how does these things come up? These things come up via the API drives. How do your vendors do it? The vendors do it in a very simple way as well, that they use the APIs for attack and they send this information there using sticks and taxi feeds. If we go back into digital forensics now and see, and see what is happening here, when we start looking at the network analysis of this, what we started looking at was what were the domains that were connected, what were the IPs that are connected, what are the ports that are connected. What we do for this is, as per process, we start looking up in terms of were these domains legit or not. Don't look at vendor information. Autofocus is a product given by Palo Alto, right, which uses this information. You can get this from a simple search on VirusTotal as well. So process information. Secondly, what we're looking at, domain name information that we're getting, plugging this forensics into CTI to gather information in terms of are these domains actually malicious or not. If you look at multiple domains that you're capturing, you can see whether they are DGA or what are the communications that are there. Now you're saying that these domains can be multiple in number. Yes, that's why we flag them from the API itself by sending each domain and matching that and saying what is the score that we get. Is this making sense to you? Yes, no?
Yeah.
Okay. The next thing you can check around the DNS activity is the response that we got. So it can be domain names are clean, but the response that we were getting in terms of the IP addresses were actually malicious. So doing a match on both is something which is important. Now, these kind of things, when we are generally looking at an attack surface, you have gone to the C2C or malware kind of thing, your EDRs, etc., will stop the specific process. But have any other communications happen to say said IP address or said domain in my entire environment? That is something what we're trying to look at. So from a process based, you saw there was a domain, you saw there was a URL, and there was a file name which was triggering this. You picked out your user ID from your Active Directory logs. You found the user ID that was trying to make this. You picked out the domains and the IP addresses. And from threat intelligence, you picked out what were the other hashes that were there, what are the related domains that were there to this domain, what are the related IP addresses. Okay. Further, what you can do is take it to the incident response process. Are you guys familiar with the incident response process? Folks, are you guys familiar, not familiar?
I doubt that at least few of us will not be aware.
Okay, all right. So in very simple terms, any incident that occurs, there are certain phases that get triggered out of that incident response. Everybody does a little bit of derivation to these things, but in static ways. The general incident response process follows detection, where how did the attack get detected in the first place? Was it by somebody looking at a log and they triggered it? Or was it one of your sensors which actually triggered it? By sensors, I mean devices, right? Secondly, what happens is you get into analysis phase where you look at more and more information in terms of that alert. You pick up domain names, URLs, IPs, processes, all of that information, and you start confirming it with TI sources that we get. And we look at how and when were these kind of machines being spoken to. Is there anything else that is available or any other machine that was talking to it at this point of time? Was there any lateral movement happening? Once we analyze, two phases launch in parallel, which is basically containment and eradication. Containment's sole goal is to capture the event and stop it with the existing framework itself, that you do not let it spread further to any other machines. Eradication is how you start cleaning out those machines or cleaning out your network. And post incident activity is something like lessons learned kind of thing, where we take this back to the entire process and how we can improve our detection, what kind of changes can we make so that we can actually stop this to come to say containment and eradication in the first place. So in terms of malware incident response, what we was talking about, the idea is pretty similar. How you can start looking at an alert, how you enrich the data with whatever steps that I just showed you. You look at the compromised hosts, etc. You want to disable their IDs if you think that's the ID that's being used and being spread around with communication, and then gathering intelligence about that. Eradication pretty standard. It'll be if it's an endpoint, you start blocking access on it and you reimage the machine. The most important aspect here that I would like to talk about will be the post-incident activity. So what we tend to do over here is that you pick up your TTPs that you've got and you start injecting them into various frameworks that you're getting and mapping them back to see whether you knew any adversary. If they did not match any adversary, you just keep these TTPs listed. Why? Tomorrow, if a similar incident happens and you have the TTPs already there, you know what exactly you are facing. You don't need to get into analysis again. You don't need to get into uh, shifting that alert to say I will go investigate it and then see what is happening. If TTP 1, 2, 3, 4 is matching, you immediately know that this is no longer a low severity attack. You can just similarly put it out as an attack or put it out as a medium or a high level attack and go ahead and take the actions that you've done previously along with the incident activities basis on the lessons that you've learned. If we were not doing this, we would basically have to channel the entire incident response channel again, where an analyst is sitting working on each step again and again to figure out what is actually going on. And I'm not talking about just on the machine, I'm talking about the analysis that we've done here. Does it make a little bit of sense now why we require this and how it actually ties up to a real world SOC kind of incident scenario, what we're looking at?
Yeah, it's clear.
And just to reiterate, I don't know how many companies do this right now in terms of getting into detailed analysis behavior of every say malware attack etc that they see, because I know for a fact that people when they see malware activity they block it, they remediate it, they clean it out, but they do not build TTPs for it. Tomorrow you see another attack like that, you treat it as a completely new malware, you follow the same kind of steps again and again without improving your entire process of detection. If you look at this, comparing it to the pyramid of pain, etc., and the mergers that we were doing in terms of the attack life cycle, you are now adding more and more data in different phases. For example, in tooling, you're adding more data, in detection, you're adding more data, in IOCs, you're adding more data. So, does threat intelligence always have to be external? No, it does not have to be. Can you build it in-house? I'm not saying build it, but can you gather this information and keep it in-house? Yes, you can. To give you another example for something like weekly hunting, what people do, if I look at a use case for like one thing where we say, okay, exfiltration is happening, right? What you would do is hunt for processes communicating with, say, suspicious protocol attributes. That's something that I'm going to do this week. What you would end up doing is you would start looking for people communicating to any known C2Cs over suspicious ports. For example, there was a HTTP request being made without any user agent being flagged. If you want to look at lateral movement, right? People trying to spread from one machine to the other machine, you can very easily come and see, okay, these are domains, this similar machines were triggering similar kind of events or domains, right? They were talking to similar kind of hash values that we had, and they all look similar in terms of indicators which are spreading across machines. If you further look into process activity for these kind of things, what you would start seeing over here is, if you see the domain names, they are trying to spoof Google domain names. So what generally happens is on DNSs, people whitelist star.google.com, right? Or close adversaries to that. If people want to launch phishing campaigns, etc., from this, they can very easily do it because people will not be that attentive to look at it. So in an automated hunting example, what you do is you get all your available engineers from SOC, you set out a hunt job, you get the hunt data and you assign each hunt. How do you assign each hunt? You have to start defining your use cases. How do I get these use cases in the first place? You have to see your top 10, 15, 20 priorities that you're getting in terms of alerts from your systems. How did you get this? Because you're mapping every incident back to attack.
But Dhruv, with I mean, talking to the real-time world, is this really, I mean, the feasible to map each the TTP for each threat? I mean, because in the organization, in a per second, there is a huge number of connections, and if they start building the TTP and the threat basically the actors for each connections, then the SOC will be overburdened, and in
So
fact, they will not be able to do it.
absolutely agreed. We are not doing this manually, number one. So what the
Mhm.
examples that I'm showing you are specific hunting examples that I showed you, but the data that is going into different phases for attack will be happening in an automated fashion, which some SIEMs are doing in today's day and age, but you can do with the API as well. You don't need to sit and do this manually. You can start doing this for in an automated fashion as well. For every alert or trail that you see, you will be able to start conquering the attack phases individually. Or if you start looking at it over a time frame, you will start seeing all of them. So for example, if you're seeing just one, let me just take a very real world example, right? One, your DNS logs are coming in. You see a DNS query from your system to www.google.com. Another system fires a DNS query to some malicious domain xxx.com. A third system fires a connection to say 1.com. What attack would do is it would put you under DNS reconnaissance as a phase, map you to google.com, map second system to xxx.com, map third system to 1.com. As a SOC analyst, what I would see is in the last 30 minutes, the only attack phase that I'm seeing is DNS querying or DNS exfiltration, for example. I did not see any other attack phase getting triggered. But say in the next 2 hours, one system is compromised and it has generated logs and it is going to the attack framework. What your analyst would see is in discovery phase, one thing got flagged, say in tampering, another thing got flagged, in exfiltration, another thing got flagged, right? Now in front of them for the last 2 hours, all the logs, they are going to see a channel which is going to basically start highlighting on the attack phase what is happening. I will not expect your SOC analyst to say, hey, APD 30 is happening, because that is something that they cannot know. Even if you ask me, I cannot know. But if you take the API and you hit, these are the tactics that I'm seeing, give me the groups against this, it will give you the groups. Because for every groups, the tactics are mapped. And how they are mapped also, I'll show that to you. So we might have not been able to pull it from the API, but I can show this to you from the GUI itself. If you go to groups over here, these are all the known groups that you see. For example, if I look at this, you will see all the techniques used that this group is doing. So what your SOC analyst would be seeing would be something like this. Would they know this is APD 39? No, they would not know. That is where they hit the API, they pass all the techniques that they have, and the attack framework returns to you that this is an APD 39. The good part is we also have mitigation techniques for each. So how you can mitigate everything, you can also get that information here. So when I was trying to connect to attack using the APIs, I was doing nothing but trying to get tactics, techniques, mitigations, and groups for you. So I'm just connecting to this. Does this make sense?
Yeah. So in this case, generally through the complete dependencies goes to the security provider, because they are continuously doing this like the kind of the research based on their analysis, and they're creating like the MD checksum or the signatures in the databases, and those databases they are the publishing to their customers.
Yes, in terms of paid feeds, they are doing that. If you seek this information from open source feeds, you can get that. What I'm trying to say is, why not build your own data structures as well? Because nobody would know your business like you do.
So, I mean, what really it says as per your experience, Dhruv, how much time basically it will take? For example, in a SOC team, close to 5 members are there, and they have a huge and a bunch of logs, basically the millions of logs in a per day basis. So, is this really feasible, like for a SOC team to build this kind of the platform and APT a framework and analyze it?
If you have, see, like I said, this is for threat hunting teams as well. If you don't have a threat hunting team, the only thing that you can do is aid CTI,
Hmm.
right? If you do have a threat hunting team, then they can look for other things as well and flag it. But what your SOC teams can do, if you want to get just additional information in terms of mapping results out to threat groups, that is something that you can very easily do no matter what the size of logs is, because that is going back automatically to attack. They don't need to do anything passively. The only thing what they will see is they will see an alert coming up by saying last 45-minute activity looks similar to APT21, please verify. Now, if you tell me that they do not have the time to go see last 45-minute activity and why it's looking similar to APT21 by opening the attack framework itself, that is something that I would still question. And there are still ways of doing that in an automated way as well.
Okay. I think
And
this is more interesting topic, Dhruv. Is there any possibility, I mean, from your side, that if you can take one example, and I have seen that ELK, I mean, in our curriculum here. So SEIM open source can it will push the logs to the ELK, and from ELK, if we filter it out based on that, if we can try to create a APT like the
if you're using
framework.
ELK, ELK already has the capability to map it to attack.
Hmm.
So if you want, in ELK, I can show it to you already, that how the attack framework basically is linked already.
Hmm.
So in the Elastic Logstash Kibana structure, it's already doing the attack mapping for every log.
So
That's
it's a predefined, but what about if we want to customize our own?
no, what I'm saying is that it's already sending logs to attack framework and mapping
Hmm.
every line for you. So further activity, obviously enhancement, that's something that you will have to do. See, the automatic response from elk is paid,
Hmm.
right? But sending it to attack and getting that view for you is free, but you will have to have a look at it. So what I can do is, if you probably give me some time or in the next class, I will show you how we have implemented it. I will have to take screenshots and mask out a lot of information, but I can show you how this has been implemented in a real world scenario.
Yeah, thank you so much. Yeah, that would help.
Perfect, I'll do that.
Thank you.
All right. Further, what you can get into is around the incident types, around sub playbooks you can categorize above, also around containment, also post incident playbooks that you can use, right? So there are multiple playbooks that are available. You can keep using them again and again. You can also define static practices for your SOC as well. So it's not only alerting, but if you are using a SOAR platform, you can start plugging that into your SOAR platform to auto remediate such kind of things by defining static playbooks. So there are multiple ways of even automating the part that you're getting information, you're looking at it, you're passing it into your attack framework. From your attack framework, once it looks suspicious that it's close to one APT group, you can define a playbook for each tactic, how you want to mitigate it. Playbooks are available. We can automatically remediate any known group of attack using SOAR today. Now, where you say that I need people, I need 5 engineers, billion lines of logs. I don't need even one engineer. I just need your process to be strong enough, and you can trigger off any APT or known group of attacks if they target your organization just by using SOAR, by using attack, and by using a few playbooks that are available. Even they're available in open source. You can also get them from your vendors as well. But you can very well kick this attack off completely, right from detection to containment to post incident as well, just using automation. And I will show this to you. This is already implemented at our end. I will show you some screenshots. But that is where I say I don't agree with people dependency, because if you're saying that there are 5 people with even 1 lakh line of logs, they're already burnt out, according to me. Any questions on this front?
Yeah, no, I'm good.
Perfect. All right, folks. So let's break for lunch then. We'll come back at 2:30. Hopefully the script start working and I can show you the data that we get from attack itself. In case that's not happening, whoever system it is working on, I will show it to you on that system. And we can basically then just get into MISP as well. And then there'll also be a quiz.
So quiz, I mean, what time will be the quiz?
Around 3:30.
Okay.
Yeah. And it's open book, open internet, open PPT, open recordings, whatever you want.
Sure.
I'm not going to restrict you, but just apply your mind, read your questions. You will get them. If you've attended the classes, you should be able to easily get it.
Sure. We will
And
try.
please make sure you concentrate on the nots and the ors of the questions. So please just make sure you're reading them. Right, folks. Thank you. See you after lunch.